Deep Reality is a highly skilled team formed as part of the NSF Convergence Accelerator program with experts in construction, civil engineering, computer vision, geomatics, building information modeling, and laser scanning from several academic institutions and industry. Our passion is to harness the power of artificial intelligence and deep learning to digitally model reality to support communities with management of the built environment. Our product, InstaTwin, rapidly generates detailed building information models from point clouds in minutes compared to weeks or months as is normally required. These models are key to understanding, managing, and improving the built environment for all residents. So why are we doing this? The built environment comprises the buildings we live in, work in, and shop in, as well as the infrastructure that provides us with our basic needs such as water, fuel, and transportation. Because of the need to support these many purposes, the built environment is complex and dynamic. Buildings use 40% of the world's energy. 50% of our building stock was built before 1980 and are not energy efficient. 25% of construction project costs are waste, and construction in general is slow to adopt new technologies. There is a 20% annual growth in smart buildings. Building construction is forecasted to be an $11 trillion global market by 2024. Because of this scale, just a little bit of effort to improve efficiency in the construction and management of buildings can have a huge impact on our environment. So how can we make our buildings more efficient and sustainable to keep us and our planet healthy? It all starts with having a digital model representing the real world. A picture is said to be worth 1,000 words. A model can be said to be worth 1,000 pictures. Building information modeling, or BIM, is an effective way to manage the many components of the building. It serves as a common, convergent platform to connect architects, engineers, HVAC, and more so that everyone is on the same page. It is a tool that can be used to analyze the energy efficiency of a building and determine appropriate retrofit strategies. However, making accurate, detailed models of the built environment is complex, both in terms of collecting the information and processing the data in advanced software. Given the thousands of objects in a single floor in a single building, this process is the primary barrier to being able to produce these models and thus impedes the efficiency with which we can manage the built environment. Given these challenges, InstaTwin is the answer. InstaTwin is a process to take detailed laser scans and use AI technology to convert them into models ready to be used by professionals. InstaTwin is a 3D analogy to OCR technology, or object character recognition technology, which is used when scanning a document. When scanners first came out, we could scan a document and we would have a digital copy as an image. But we couldn't directly access the words, which limited our ability to extract the information efficiently from those documents. That required OCR to extract the words from the pixels. Likewise, with 3D laser scanning, rich information is captured as a 3D point cloud, but we need an OCR equivalent to convert those points into the model. InstaTwin is that OCR analog for 3D modeling. It first segments the points. It then identifies intersections of segments to define edges, walls, ceilings, floors, and more. As an output, you get the model with attributes or information associated with the objects present in the scene. You can also extract a 2D floor plan from the 3D model. To develop InstaTwin, we engaged a community of experts who thoroughly vetted the platform to ensure it will robustly meet intense industry demands. Come, win with InstaTwin and visit us at the NSF Convergence Accelerator Expo.